We're going to practice simplifying radical expressions a little bit more. So let's go ahead and start with number 1, the square root of 72, r squared u to the third into the fourth. So let's start by figuring out what perfect square goes into 72. The first number that comes into my head is 9, so I'm going to go ahead and write this as 9 times 8. And then I have r squared, which is even. U to the third has an odd exponent, so I'm going to write it as u squared times u. And then into the fourth has an even exponent, so I'm just going to rewrite it. And I'm going to take out the perfect squares. So I have the square root of 9, so I'm going to take that out, and that's 3. Go ahead and cross that off here. And then I have r squared. The square root of r squared is r. Remember, when you're taking the square root of a variable, you're going to take the exponent divided by 2. So 2 divided by 2 is 1. Go ahead and cross that off. The square root of u squared is u. And then the square root of into the fourth is n squared, because 4 divided by 2 is 2. And then inside that radical, I'm left with 8u. So you might look at this and think, all right, great, I'm done. But you're not that lucky. You're not quite done yet, because there's a perfect square that's a factor of 8. So that means that we just did not find the largest perfect square that goes into 72, which is fine. We just have another step to do, because we need to simplify this a little bit more. So let's go ahead and rewrite this 3 run squared. And then inside the radical, 4 goes into 8, so that I'm going to write 4 times 2 u. And now I can go ahead and take out that square root of 4, which would be 2. So I'll have 3 times 2 run squared outside of the radical. And inside the radical, I'm left with 2u. One more step to simplify this, because I can do 3 times 2. I know that's 6, so I'm going to rewrite this as 6 run squared times the square root of 2u. Now every part of this is simplified. All my like terms are combined, and I have no more perfect squares under the radical, under that square root sign, so I am done, and I can move on to number 2. All right, number 2, 9k times the square root of 64k to the 7th, u to the negative 2. So first, let's look under that radical. So I'm going to go ahead and rewrite this 9k. 64 is a perfect square, so I can write it as 64, or I can write it as 8 squared. K to the 7th has an odd exponent, so I'm going to rewrite it as k to the 6th times k. And then u to the negative 2. Even though it's negative, negative 2 is still an even exponent, so I'm going to write it as u to the negative 2. And then I'll deal with that negative a little bit later. All right, so let's go ahead and simplify this. Take out our perfect squares. So the square root of 8 squared, or the square root of 64, is 8. So I'm going to have 9 times 8 outside of my radical. I have that k outside the radical. So now I have k to the 6th. The square root of k to the 6th is k to the third, because remember, we're taking 6 divided by 2, which is 3. And then I have u to the negative 2nd. Negative 2 divided by 2 is negative 1. So I'm going to have u to the negative 1 outside the radical. And then inside, I'm just left with that extra k. So I need to remember to add that on to the end. And now I can simplify this. I know 9 times 8 is 72. I know k times k to the third. In order to multiply those, I need to add my exponents. So 1 plus 3 is 4. And I know that when I have a negative exponent, that I need to take the inverse. So I'm going to move that down to the denominator and make that exponent positive. So a to the positive 1 would just be, or u to the positive 1 would just be u. And then don't forget that square root of k tacked onto the end there. This is as simplified as it can be, so I'm done and ready to move on to number 3. All right, number 3, I have square root of 28, k squared s u to the 11th. The largest perfect square, that goes into square root of 28. That's a factor of 28 is 4. So I have 4 times 7. K squared, 2 is even, so I can rewrite that. S, and then u to the 11th. 11 is odd, so the largest perfect square, that's a factor of u to the 11th, is 1 less. So u to the 10th, and then I have a u left over. Now let's go ahead and take out those perfect squares. So the square root of 4 is 2. Let me go ahead and cross that off. Square root of k squared, 2 divided by 2 is 1. So I have a k. Making sure I'm being very organized and keeping track of all of my variables and numbers. U to the 10th, the square root of u to the 10th, u to 10 divided by 2, which is 5. So I have u to the 5th. And then everything else is left under the radical. So I have 7su inside that radical. This is as simplified as it can be, so I'm done with this problem. Moving on to number 4. I have 3m cubed a to the 1st, t to the 4th, h to the 9th, times 8 times the square root of 24m a cubed, t to the negative 2, h to the 1st. So I'm going to multiply my coefficients first. 3 times 8 is 24. And now I'm going to multiply everything inside of the radicals. So I'm going to make a big old radical sign. I'm going to put it all under 1. I know I have 1 times 24 under that radical. So my coefficient is 24 inside that radical also. Now I have m to the 3rd times m. I know when I'm multiplying my variables, I'm going to add the exponents. So 3 plus 1 is 4. A times a to the 3rd. Once again, I have 1 plus 3, which is 4. T to the 4th times t to the negative 2. So I have 4 plus negative 2, which is a positive 2. And then h to the 9th times h to the 1st. 9 plus 1 is 10. And now I can simplify. So I have 24 outside. Inside that square root, the largest perfect square that's a factor of 24 is 4. So I have 4 times 6. M to the 4th. 4 is even. Once again, 4 is even. 2 is even, and 10 is even. So I'm going to rewrite all of those variables and exponents. Now let's go ahead and take out those perfect squares. So I have 24. The square root of 4 is 2. So I can pull that out of the exponent, cross it off, staying nice and organized. Skip over the 6. Square root of m to the 4th. 4 divided by 2 is 2. So I have m squared. Once again, square root of a to the 4th is a squared. Square root of t squared, so 2 divided by 2 is 1, so I just am left with a t. And then square root of h to the 10th. 10 divided by 2 is 5. So I have h to the 5th. And now inside that square root sign, all that I'm left with is a 6. I can simplify this one more step. I can multiply that 24 times 2, which is 48. And I'm going to rewrite the rest because it's already all simplified and combined. So now I have my final answer. And I'm going to move on to number 5. So now when we're dividing, we're going to first divide everything that's under the radicals, put it all under one radical if we can, and then simplify. So I'm going to do my coefficients first. 45 divided by 5 is 9. When we're dividing our variables, remember that now we subtract our exponents. So r to the 3rd divided by r to the negative 1, I'm going to do 3 minus negative 1, which is the same as 3 plus 1, which is 4. A to the 1st divided by a to the negative 13th, so 1 minus negative 13, which is the same as 1 plus 13. So I have a to the 14th. And then p to the 8th divided by p squared. 8 minus 2 is 6, so I have p to the 6th. And now I can simplify this. Every part of this square root that's under the square root sign is a perfect square already, so I'm going to go ahead and pull out all my perfect squares. The square root of 9 is 3. The square root of r to the 4th is r squared. The square root of a to the 14th is a to the 7th. And then the square root of p to the 6th is p to the 3rd. This is all simplified and combined, so I'm done with this problem.